Faster-than-light travel still seems like pure science fiction, but it could soon become a reality. Scientists have finally discovered a new way to travel at speeds 10 times faster than light. Other research teams have made amazing breakthroughs in warp technology. In practice, this could mean that in just 10 or 20 years, we could have the first prototypes of spaceships capable of traveling enormous distances in ever shorter times. The scientists, who will be the first to make faster-than-light travel possible, can be sure of eternal fame. For a long time, warp drive was considered pure fantasy by science fiction writers. But then, serious scientists took up the idea. Since then, there has been a growing understanding that this drive is not a pipe dream, but can become reality. And soon. Several research teams around the world are now working on putting into practice a drive that sends matter through the universe faster than light. The state of the art is astonishing. In just a few years, initial ideas have developed so rapidly that experts expect the first real prototypes to be used in space travel soon. The starting point. The speed of light as the limit of space travel. Since the dawn of modern physics, the speed of light has been considered the absolute upper limit for any form of motion in the universe. Albert Einstein's special theory of relativity, formulated in 1905, established a fundamental rule. Nothing with rest mass can move faster than light in this universe. This limit is not just a technical hurdle, but is deeply embedded in the structure of spacetime. The closer an object with mass gets to the speed of light, the more energy is needed to accelerate it. In theory, this means that accelerating to the speed of light would require an amount of energy approaching infinity, and that's not possible with our current technology. From a purely physical point of view, this rule initially made the idea of interstellar travel, as described in science fiction novels and films, impossible. The speed of light in a vacuum is approximately 299,792,458 meters per second. A ray of light, therefore, takes around 8 minutes to travel from the Sun to Earth, a distance of approximately 150 million kilometers. On a cosmic scale, this enormous speed seems almost meaningless. Light from our Sun takes over 4 years to reach the nearest star system, Proxima Centauri, and over 100,000 years to cross the Milky Way. Space travel, as we know it today, moves at only a fraction of that speed. Even the fastest probe, the Parker Solar Probe, would take over 70,000 years to fly to the nearest star. This reality has long confronted us with a sobering fact. Our current technology does not allow us any serious prospect of interstellar exploration within human lifetimes. Even with the most ambitious conventional propulsion systems, reaching the nearest star systems remains a matter of centuries or millennia. Physics has long set hard limits, but it's precisely this challenge that a new generation of scientists has taken up. Engineers and visionaries believe that the limits of physics can be overcome. The necessity, why faster-than-light travel is more than fantasy. At first glance, the idea of traveling faster than light may seem like an entertaining thought experiment from science fiction. The idea is fascinating, but beyond the realm of possibility, and probably unnecessary, right? Upon closer inspection, however, it becomes clear that faster-than-light travel is more than just a fantastic idea from movies or books. It would be a necessity if we as a species want to survive. There is not a single planet in our solar system that we could colonize as an alternative home if conditions on Earth one day become uninhabitable. Warp drive and faster-than-light travel could then become essential keys to the survival of human civilization. Humans are explorers. The desire for interstellar exploration and discovery of the universe is clearly evident in our science fiction ideas. And it's not just space enthusiasts or ordinary people who dream of this. Scientists also dream of one day exploring distant worlds, cosmic nebulae, and other regions of the universe. Earth-like planets, such as Proxima Centauri b or the TRAPPIST-1 system, which has several Earth-like planets, are only a few light-years away. And yet, the distance is unreachable with today's technology. With faster-than-light travel, exploring these worlds would be feasible. The problem, why faster-than-light travel was considered impossible. The theoretical and practical obstacles to faster-than-light travel have long seemed insurmountable. Scientific limitations have so far relegated the topic to the fringes of physics or to philosophy and pure fantasy. Impossible, said the old heads of science. Possible, said a few visionaries and exceptional researchers, such as mathematician Miguel Alcubierre. Achieving the speed of light in a vacuum with conventional propulsion systems may be impossible. Einstein's limit is a universal limit, but the formula describes only one dimension of reality. We are in an age in which quantum realities are gaining importance. Classical physics is reaching its limits, and aspects such as antimatter, dark matter, and exotic forms of energy play just as important a role in physics as the classical ideas of matter and Einstein's set of rules. These new forms of physics open up new possibilities and energy relationships. An object with mass can also move through the universe in ways other than overcoming classical spacetime with the help of fuel, power, and thrust. To actually reach the speed of light in Einstein's world, an infinite amount of energy would be required. But in the world of quanta and exotic forms of matter, spacetime can be manipulated. A spaceship would then slip through a fold in space and time. In this way, humans would not be exposed to the effects of acceleration. Phenomena such as time dilation, length contraction, and relativistic mass increase would not occur. These new paths are no longer mathematical curiosities, but experimentally confirmed phenomena. If a human being in a spaceship in the universe of classical physics were to move faster than light, causal relationships could be reversed. Events could bizarrely appear to wipe out their own causes. This so-called causality paradox calls into question not only logic, but also the stability of physical systems. Alternative concepts, such as creeping through space-time using warp mechanics, circumvent old problems with new ideas. Advances are delivering ever more fantastic forms of propulsion. The original calculations for the Alcubierre drive still required elements, such as exotic matter, with negative energy density. Now, there are already practical ideas that do not require any exotic forms of matter at all. The models are not yet realistic on a large scale. Many show instabilities, uncontrollable energy fluctuations, or even the risk that the drive could trigger a catastrophe in the space-time structure. Despite these weaknesses, interest in solutions is greater than ever, and there are probably several secret projects working on solutions worldwide. We can be sure that the scientists at SpaceX are working on the problems. NASA also has strictly protected scientific areas that are said to be feverishly working on technologies for space-time distortion. The solutions: 3 very real models for warp drive. Despite all the physical hurdles, the idea of warp drive has undergone an astonishing development in recent decades. The path from a pure science fiction idea to a mathematically sound theory has been rapid. At the heart of all new ideas is always the same principle. It's not the spacecraft that moves through space, but space itself that is distorted. Warp means to distort. Through this restructuring of space, a spaceship can slip through the complex space-time structure of Einstein's physics, which ultimately means that Einstein's physics is circumvented. 3 completely new concepts now suggest that travel through time folds may soon be possible. 1. The Alcubierre drive. In 1994, the Mexican researcher proposed the first functional model for faster-than-light travel based on the general theory of relativity. His idea was a space-time bubble surrounding the spacecraft, within which no actual movement takes place. The space in front of the ship is compressed, while the space behind it expands. In this bubble, the ship could apparently travel faster than light without violating the theory of relativity. However, the model requires immense amounts of so-called exotic matter with negative energy density to remain stable. And this energy has its pitfalls. To this day, we do not know for sure whether it exists. 2. The Neterio drive. Related to this is the concept of the Neterio drive, a modification of the Alcubierre model. Neterio dispenses with the expansion/compression of space and instead focuses on a geometry of space displacement. The structure through which the spacecraft slips is different, but the energy requirement is solved in the same way, namely, through exotic forms of energy that have not yet been sufficiently researched. Among experts, the Neterio drive is considered mathematically more stable, but still as impractical as the Alcubierre drive, simply because there is no access to the chosen form of energy. 3. Harold G. White's warp bubble. Things get exciting with Harold G. White's model. The NASA researcher and head of an experimental laboratory for advanced propulsion in Texas proposed an adapted warp concept with much lower energy requirements in 2021. Through clever geometric adjustments to the warp bubble, the negative energy required was reduced to a few hundred kilograms. White found a real-world application for a warp bubble that occurs naturally. While experimenting with the Casimir effect, White discovered warp-like structures in the nano range. These real and natural warp bubbles are only fractions of a millimeter in size. But if the system exists on a small scale and in a natural way, it could be transferred to larger scales. That's exactly what White's team is currently working on. This does not give us a functioning propulsion system yet, but it's promising proof that the warp concept actually exists in nature and that it's possible to access it. Thanks to this discovery, warp geometries are no longer purely hypothetical, but have become real and tangible. Bonus: the Potsdam discovery. Let's move on to the latest discovery by a German research team. In 2024, a team at the University of Potsdam worked on simulating gravitational waves using warp propulsion concepts, and the results could truly open a new chapter in theoretical physics. In complex computer simulations, the scientists investigated how space-time distortions, such as those that a hypothetical warp drive would generate, would appear in gravitational wave patterns. The idea: we could find traces of warp bubbles created by other species in the universe. For example, in observatories such as LIGO. If we had the pattern, we could replicate it. These signatures could also come from natural warp bubbles, such as those observed by White's team via the Casimir effect. The Potsdam team has thus provided a methodological approach for virtually copying futuristic propulsion systems. This would allow us to simply copy our progress from superior species. The future, visionary outlooks on interstellar space travel. Despite the progress made, the first real warp spacecraft is still pure fiction. But scientists are optimistic. We could have the first prototypes in 10 or 20 years. More and more physicists, engineers, and even space organizations consider access to the structure of space-time itself to be more realistic than classic types of propulsion. Advances in the interpretation of relativity theory and quantum mechanics will greatly advance our space travel in the coming years. The basic idea that space is not fixed but can be shaped, stretched, and compressed could enable space-time architectures that produce much more than just spaceships. Along with this, we will understand more about the structure of the universe and our possibilities as humans within it, and perhaps rise to become a superspecies. The long-term implications would be fantastic. Travel to star systems in a matter of days or hours. Interstellar communication via space-time channels. New forms of energy generation. Access to new physical states. Changes in reality itself. All of which would completely redefine our relationship to space, time, and distance. Click subscribe now and enjoy new videos on a regular basis.